Right, okay, I think this is all active now, and this is a live stream for, and I'm just going to hit refresh and get it actually working as well so that I can see everything popping up. But this is a live stream for blockchain in Python. Blockchain's been around for a decade, there's nothing new, and I've created blockchains in the past in Node.js and in Python, and I just thought I'll go and have a look at some code, some implementation, because now it's much more improved compared to where it used to be. So that's basically what I'm going to do, and I'm just setting up the actual live cast as we speak, and I think we've gone live, so I'm just going to also, if I can, I don't know if I can do this, but somewhere in the view I can. Stats full screen, multi-view, docs. Yeah, there's a little chat section here, so I'm just going to hit test in that. Test, that'll go to top of chat, so I just want to do live chat. So there is a live chat section as well, and I've just hit a little test thing in there. So I'm hoping, yeah, that has worked, because that's popped out. And I might actually do a share as well. So share, copy this link, and I'll post that into like Twitter, which is now called x.com. So live cast on YouTube about the blockchain. Blockchain's a keyword. YouTube is a keyword. And I'll paste that link and then hit post. So yeah, I'm going to go through something that I literally pulled out of the web. Actually, that's what I'm going to be doing. And the position of where I was doing it, so let's get this all up. So I've got my VS Code open, and I'm just going to edit it as I go along as well, just to kind of like make it a little bit more in the style. There's nothing wrong with this, by the way. They've done comments and things, so I'm just going to really change some of those. But I'll copy that and paste it there, because that's what it basically is. And it's going to implement this into a Flask app. A Flask app is a web page, basically. So Python's got a few different web frameworks, Django, Flask, and I think Faster API now as well. Flask is supposed to be an easy one. And well, actually, one of the things that I was doing was, there's some comments on this. I'm going to remove some of these comments, but one of the things that I was going to do, well, yeah, I'll be testing this Flask app. I'll have a look. You'll see that I did have a look at how the Flask app works. But basically, it doesn't need that many imports. We've got a datetime import here, which is the standard datetime library. Then we've got this thing called hashlib, and that's basically there for creating hashes. I guess we'll see like that manifest itself. Then we've got JSON again. These are all standard imports. And then finally Flask, and we're using two things out of Flask. One is this class over here. So Flask objects, it implements a what? WSGI. I guess that's what you see is what you get, or something like that. Just let me close all of those things up. And I'll put my volume on mute as well, because I don't want to be disturbed. Always forget to put volumes on mute. And close other applications too, just so that there's no disturbance. Yeah, so this is Flask class here, that's imported from the Flask module, and also this JSONify, which is a function which serialize serialize the given argument as a JSON and return a Flask response. Basically, it turns, I believe it turns this into effectively it turns it into a JSON basically. And yeah, that's pretty much it. So there's two components of it. One is creating this blockchain, and maybe in a way that's the most important part of it. And the second one is to create this Flask app, which comes somewhere down the bottom. Now, I did have a Flask application before, and here is the Flask application. Like, this is like a test one. So, and basically this is kind of like the boilerplate. So import Flask, and then app is flask.flask. You know, I could have done from Flask import Flask. So I could have done that. You know, either way is fine. But I've just done an import of Flask over there because I guess that was just straight what was out of the documents. And then you kind of need this home page, this app.root. So I have come in and put that in to this blockchain example somewhere. In fact, I commented it out just to see what would happen, like if there was a default page. So I'm going to put that one back in, because actually, if you don't put that in, then you get like this error message on the first page, like the home page, because that's where you navigate to. It's like your home page of the app, and it just says like, you know, server not defined or server not there or something like that, and that's a bit annoying. So just going back in the Flask app bit, you create this root page, and it just says something like, you know, that there's like something at the top of the page, and then you can have these other pages that are inside of that, and they are the functions effectively, or things that you want to run in Flask. So, and here in our case, we're going to run the functions that we've created in the class. So yeah, that's pretty much it, and kind of like what page that you want it to be on as well. So, and I'm just wondering if there's anything else about that. No, I was just wondering if, for example, okay, it doesn't need to have even the same name. So this page is called admin and this function's called admin, but here this is just called, this function's just called user. So there's just a user, and actually this is the argument. If from what I recall, this is the argument that goes into it. So /name like this will actually feed itself into the Flask application. So kind of like that's what we're seeing, and I don't even really know. Let's have a look at .root. It's got these other options here, but like methods equals get. Let's have a look here. The methods parameter defaults to get, head, and options are added automatically. Okay, so we might not need the methods equals get, because basically we're getting every time. So I think we could probably ignore that. So this is just get chain here, which is so this function doesn't have to, like this name here, because this is display chain, this is get chain. So whatever goes in here, the actual URL doesn't have to match the function. Sometimes it matches the function and sometimes it doesn't. So twice it matches the function, and over here it didn't match the function. But that's basically it. And we're not passing anything into the valid one. We're not passing anything into the get chain, and we're not passing anything into the mime block. So that we're just literally running functions. So that's basically it. So really what we can actually look, so this is really like a bare bones, and I'm probably not even going to go to the actual web page itself that gets created, although when I was testing it I did go to it just to have a look. But I'm just going to go through this function really just to see what this all does. Also this class. So first of all, this is class blockchain, a class for creating the blockchain. I don't even know why I docstring that, because in the docstrings, if you've got an init that's got a docstring in it, it supersedes in the documentation the blockchain docstring. So basically, wherever I call it over here, we see what's inside the init the double underscore init double underscore, the initialization, which is also known as a constructor. So we see what's inside of that. I could have actually done this as a, like I've seen this, like I could have done this as a class instance over here. As a data class. So I could have done something like from data classes import data class, and then over here I could have done an at and then data class, and that would actually have done this init there. So again, like these are things that like you can improve over time if you so wanted to, but then basically here we just have inside our class, we just have, I just don't like this in the indentation that actually has come out of here. It's really annoying because the code that I've copied it from, and this is one annoying thing kind of like in Python really, is you inherit the indentation that's given to you, but the standard indentation is kind of like 4 blocks in the editor. So when I hit tab I get 4 blocks, and if I was to do something like now chain equals that, we can see that this squiggly underscore because of the unexpected indentation in pylons, because the indentations don't match. Super annoying. But anyway, if I did do that, I'd have to remove, like, I'd have to do my 2 spaces, and that would make it nice and consistent. But this would build the, and I'd have a create block as well, which is basically, it'd be something like this, I guess. Oh, well, actually, it's going to be calling a function, so I wonder if I could do it as a data class. But possibly you could do it as a data class. Anyway, I'm going to remove that because that's just something slightly on the side, a bit extra, just something that I saw earlier. But we have this blockchain over here. I wonder if I can somehow amend the indentation of this entire class. So what I might do, I'm going to attempt to do this, is just hit a tab on this. Here, tab. And just see where all of that's gone. I think 1, 2, 3, 4 spaces. Delete. Return. Do that again. It might whitewash away the indentations. Shift tab. That's moved them all back, and then tab out. I wonder if that's fixed it. No. Okay. Hit delete there. Return. Really annoying. I'm going to hit save. Ah, I know why. Delete, tab. There we go. Okay. We're all back to normal. I missed the 2 white spaces. White spaces in Python are critical, and I was missing those 2 white spaces, and it was throwing this error, and I couldn't see where the error was. And then I finally, I don't even know why I saw it. 1, 2. Now it's highlighted. I know, well, it's highlighted here, the indentation, but because of this. So, maybe I should have noticed it. But okay, now this is a bit more consistent, at least with the 4 spaces, because otherwise what happens is you get these lines going down through the middle, and you just get more of them, and that just gets really annoying. And actually things like this, if I'm going to do the indentation that way, if you're going to do a block, it's just cleaner because it's less spacing. So I'm really going through formatting this at the moment and not much else. But that's my block over there, and I didn't need all of those extra like lines in visualization. There was nothing there for me, so that's kind of like the dictionary as it was. But let's just see what happens, right? So we've got class blockchain here. It's a class for creating a blockchain, and the first thing we do is we construct it. So we start off with an empty chain, there's nothing in it, and then we do create block. We've got proof equals 1. I'm not like 100% sure what that is at this point of time. Maybe we could comment that. But here previous hash equals 0, and I believe that's because there is no other hashes. This is the Genesis block, effectively. So, and I presume proof equals 1 is because it's possibly the Genesis one as well. There's no proof is required for the first one, probably. But anyway, the next thing is, so once we've initialized our blockchain, so once we've done that, we've got this thing that's basically an empty a chain that's got nothing in it, basically. And then we create our first block, and our first block we're running this particular function here. So let's see what it actually does. It calls itself every method inside every method of a class. Well, normally always the first item of it is calling itself, basically. So create blockchain, we have a proof here, okay, where we've set for our Genesis block, this value is going to be 1 in our Genesis block, and the previous hash is going to be 0. So we're creating this block, adds further blocks into the chain. So it's our first one, and we're actually specifying index. Okay, so our block is, I think that's what we're self.chain. So each block is just effectively a dictionary. That's all it is, or a hash table as it's called. So it's a dictionary, and each dictionary's got 4 items in it: an index, a timestamp, some kind of proof, whatever that is, and a previous hash. And that's pretty much it. So our Genesis one has a previous hash equal to 0 over there, because it's coming from here straight away. It's also got a proof equals to 1. So the only thing it really has is a date time, which is now, and the length, which self.chain, the length of self.chain plus 1. So it's going to be of length 1, because self length.chain is 0, and then we're going to increment that by 1, so it's going to be an index of 1. And that's pretty much it. And then what do? We append that into the blockchain. So that's basically it. And I guess one thing is, here we've got a Python list, so like an empty list. A Python list isn't the most efficient thing, but really, like, you're going to have a linked list, because one thing about the blockchain is we don't know, like, unlike a normal array in memory, where we can gain, like, these great efficiencies by knowing the size of the array and sort of like what's in the array. Well, we can know what's in the array, so we could set that, but we don't know the size of it. So it would be something like a linked list, or like a doubly linked list, or a singly linked list, but it'd be like a linked list. So the list in Python effectively does that quite nicely, so we can keep on adding our blocks into the chain. So that's what we do, and that's what this create block function does. And I'm just going to check if there's been any comments. I don't know if there has or hasn't, but I'll have a little quick perusal. No, there's been no comments. So that's that. So we've created the block, and the next thing is to have a function that looks at or gets or displays or shows the previous block. And that function here is print previous block, and all we need to do is reference ourself and then return self dot chain -1, which is, I guess it's the index. This is the last index in a list. So if we've got a list, so my list, and it's so like 100, 200, 500, 20, 30, something like this. The index of -1 is basically just this last item in the list. So basically that's all it's doing, is getting the last item from whatever list that we've got. That should be my list over there. So that's just basically returning the last item from a list. And what else is there? Okay, so the proof of work. So this is an interesting one. Previous proof, new proof, check proof. Okay, right. New proof equals 1. Interesting. Check proof equals false. All right. So I presume that we're going to stick it to true at some point in time and change it to true. In fact, I see here that we've got to change. We're changing it to true there. While check proof is false, so this loop is going to keep on running, and this is the hash lib. So hash operation, so it is our variable that we've set up to get the return value of this hash library SHA, this hashing thing. And I wonder if I can. I will put it into Bard AI. I'll start a new chat. And what is hash SHA in Python? Question mark. I'm literally asking what the hash SHA is. Okay, so this hash lib basically is a cryptographic hash function in Python standard library. So it's in the hashlib library module, as we can see. It calculates the SHA-256 digest of a string or byte data. So basically, it takes a string or a byte-like object as an input and returns a 32-byte, which is 256-bit digest as a bytes object. So it's taking this string, which is the new proof, okay, and the new proof is 1. It's taking the square of that, and let's have a look. What else is it doing? It's taking the square new proof, but I'm just wondering why it's doing new proof squared, because basically new proof equals 1, and unless it's amending new proof somewhere. Oh yeah, it is. Okay. So it's going to, it looks like it might be always changing the new proof. Okay, fine. So it's got this string. SHA-256, let's have a look. And it closes there. So minus previous proof squared dot encode dot hex digest. Hover over that. Okay, that returns back a string. Okay, fine. So this hash operation, whatever this new proof was, it gets fed into our hash, and whatever the previous proof is, so previous proof, this is like 0 squared to start with, because false was our previous proof, and it encodes that. And then if hash operation colon 5, so the first, okay, this is the nonce, basically, this bit here. If this one equals 0, 0, 0, 0, that creates, I think, extra work to be done in the system. I believe that's what it is. Otherwise, new proof plus equals 1, and it keeps on doing that, basically, until it gets the next one of these, basically. And I believe that's all it really is. So that is the proof of work. So this forces, this like while loop forces work to be done. So if hash operation, yeah, if the first, so if index 0, 1, 2, 3, and 4, so the first 5 indices, remember, like lists or arrays are indexed, the first index is 0. So if the first 5 elements of the array is these 5 zeros, then we found a proof, so it goes to true, and then the while block finishes, and we return our check proof is true, so we've got our new proof. Actually, let's have a look. I'm just trying to think of one thing though, because our Genesis one, well, okay, every time we enter the function, new proof is always set to 1, and the previous proof is set to 0 in code. If check the proof. So what's going to happen here, interestingly, is I could actually take this out and actually run this separately. So one of the things I'm going to do is do a hash like that. And I could actually run it, but what I'm actually going to do is take this separately out, because this is our proof of work, or at least this is the function, and just identify what the function's doing. So I can put this into a block like this separately to run it separately, and this is no longer a class method the way that we've got. It's our proof of work, so we don't need a self anymore. Funny enough, self was never referred to here as far as I can see. There's no selves in here. So this is actually a I can't remember what all of the headers of these things are for, but basically this is it a class method? So this one here, where is it? Proof of work. This is actually a class method, I believe. I believe it's something like that, because this self is never used anywhere. So it's kind of like just an autonomous function, as in this function never had to be inside of the actual blockchain class for it to work. And I think it's the same thing for create a block. No, create a block does refer to itself because we see it there. So this one refers to itself. This one doesn't refer to itself. So again, the hash and the proof of work both don't need to, they're both class methods basically. I should actually just check that the wording of that. What is a... I always forget these things, the different methods that go on top of them. Oops. Right, okay. A class is bound to a class rather than an instance of the class. It can be called directly from the class. So I don't think actually it's a class method. Oh, it's a static method. What is a static method? Question mark. So I think these are static methods is what they're actually referred to. So over here, this would be a static method like that. And this bit here, oops, not that one, that's not a static method, so X that one out. Because create block is referring to itself, it would be this proof of work one here. And so this one here is basically an @static method over there, but because it's not referring to itself anywhere, we can see self is actually grayed out. So anywhere where self is grayed out, it's a static method basically. I'm just looking here as well. Well, sorry, it gets grayed out, doesn't it? @static method. So again, like self is like it was never used. So yeah, those two things are static methods. I'm not a fan of the syntax, like these extra descriptors, but you know they're there anyway, so just kind of like understand what they are. So basically, it just removes the need for the self keyword, and that's basically it. But yeah, okay. Outside of that, print the previous block, proof of work. So let's just go back down here, our function, because like in creating our own function, we discover that this is. But anyway, our previous proof, it takes in something called previous proof. Now, I wonder what our previous proof was actually. I'm just trying to think what our previous proof was, because our previous proof will be presumably 1. So that'd be quite interesting. So I'm just thinking that this is 1 because when we created the block, that's our proof. So we go back and we get the previous block, and the previous proof is 1. So over here, we can actually, in our little function over here, we can do something like we'll call our function proof of work, say result equals proof of work, and here we're going to say proof is equal to 1. We're just going to assume that our previous proof was 1, and we can actually pass that into here, right? And in fact, previous proof is equal proof. It's a bit elaborate to have to do that, but whatever. I actually wonder, because we haven't doc-stringed it. This hasn't been documented, so it doesn't say like. And this is one thing about documentation, it makes life a little bit easier. So here, me as a reader, I am reading this, and it's just proof any, right? But surely this is like, is it an integer? What's coming back? Like, what can it be, or what should it be? So some good coding, some not good coding, should we say? But anyway, we can then print our result. In fact, we can just type in result here, because that will print our result over here. So, and the other thing is well, this is all in an app.run and so forth. All of this kind of stuff, normally, I would say that this belongs inside a function. So sort of like define a function. And select main. Okay, and then all of this goes into the, I'm just going to say here, this is the main entry point for the code, and inside of our code there, you know, in theory, we could have run all of this. Right, let's have a look. Y is valid, Control Z. Let's go back. Right. Okay. What can we put into our main function now, which is, I wonder if, can I just put these things in here? App. I wonder if I can, probably have to do if name equals main app run. I don't know if I can put everything inside, because I've got then our functions inside of functions. That's the main entry point for the code. And if that was the main entry point for the code, you know, I might like to. I don't like having bits of code that I like to like down below or whatever. I like to have the main bit of code here. So it's kind of like there. That's our main piece of code. But then, I'm always getting this extra space. That's again probably because of the copy and pasting. But let's just go down. Be something like if double underscore name equals main. I always get this because the intelligence. If name equals main, like run the main application, and then I don't know if this will work because will app be seen in the main app.run. Okay, it's looking like it might work like that. I'm just going to do a little check of that. So creating a Flask app, because I wonder if, oh no, here app is not seen basically. So oh, app equals Flask. I commented out the wrong piece. So that one was fine. And I actually meant it to I meant to comment out this. So, but let's just see if that runs. So that's all looking good. The IntelliSense has picked it up. I'm just going to hit an F5 to sort of like investigate the running of it. Okay. Click to follow the link. I can see the link and that is actually running, so that's all good. So I'll just go back on that then, and we can break out of this. Control C would have broken out of it as well, so that's fine. We're now running our main function from here, but the important part of that was, I wonder, is basically if I can move all of these pieces here into the main function. So let's just say they now belong here. I don't know if this will or won't work, because if I was to comment this out here now, control / so comment all these out, yeah, the app.root doesn't like work, or it's not happy there. And now if I was to put the app.root in here, also to the main function, which I'm against really doing, putting functions in functions. Okay, it is kind of like happy being there. So I can take, it looks like, comment that one out. I'll take them all in that case and place them all in there, because then I've got the if name equals main and I can control the flow of code much nicer. So we'll take all of this, copy that, and also comment it out from here and paste it all up in here just underneath. That this is where the Flask stuff happens. So, and each one of these now needs to be indented correctly. So tab, let's have a look. Previous block is not liked over there. Ah, right, okay, because I've got to do some more indentation then. Because that's going to need to be indented like that. That one will need indentation over there. Oops, tab. It will need indentation over here. Blockchain is not recognized. Let's have a look. Why is blockchain? Oh, I probably needed to create blockchain first. inside the main function. So this one here, I need to X this out and put it somewhere at the top. Paste that there. So now that blockchain works. So we've got a mining of the new block. We've got this at root thing over there. We've done that one. And we've got this one over here. Tab. Okay. So now it's looking a bit like, I guess, cleaner in a way. Run Flask server locally. So everything's now enclosed inside of our main function. And I don't know if this will or won't work, but we can certainly have a bash at it. This is if name equals main down at the bottom, and if name equals main, then everything should run. So I'll just hit F5 on this, but I will just comment this one out for now. So everything should run with an F5 button, like running the whole block of code. And I should be able to click follow link and see if that works. Yeah, it does work. Okay. So that's looking good, because I can also take one of these things here. So like mine block, I can take that and in the browser put mine block, and it does actually mine a block. When I mine a block, it gives me this back. So somewhere in the mining block, I might even put a comment of it. So this mine block, I should have a doc string basically. A block like this. Right. This is what the block actually looks like. Big chunky thing over there. So index, then it's got a message, then it's got a hash, which is some long thing, or previous hash, then it's got some proof, then it's got a timestamp. So this is literally what gets returned in the browser, right? Is that. This is what the user sees come back. Index equals 2. That's because one block's been created. Message, a block is mined. Okay. I don't know where that message comes from yet, but I guess, well, here we go. Response, a block is mined. So that's where it comes from. And then it tells us what the previous hash is and what the proof is and so forth. So I'm just going to hit stop there, because that's kind of like working, but at least we know what mine block actually does. And this is now all encapsulated in this if double underscore name equals double underscore main. So we can kind of like remove a lot of this stuff from here. So that's all gone, because that all works. And we can run our server locally. And now everything is encapsulated. So like literally everything is encapsulated. So our blockchain is here. And our main module is here. So our code looks like that basically, and then we've got an if name equals main guard at the end, so something like that. It's a bit clearer, that's all. X, right. So something like that. And I mean, I'm not sure, like anyone who knows about Flask, like by all means comment, because I'm sure that there's better ways of doing this. But I'll separate that one out. But basically over here, I wonder if on the mine block, okay, just does that. It's a little bit messy, but whatever. If I can move these functions out of here, out of the main module, to like have them somewhere else, call that like Flask modules. You know, and in fact, one of the things that I should have done is something like this, which is def run Flask, right? Which then basically well, it's actually going to be this comment now there. X creating a web app using Flask like that. And here now I can just do run Flask. Okay. Now you could say like sort of like obtrusified it in a way, but basically our main function now just runs the Flask app. This is all of our Flask stuff. So we've moved it all into a place, and this is our blockchain. So it's kind of like a little bit clearer. We've modularized it, and when we run stuff, this if name equals main, so like runs. Now I can switch everything off here because I can just do pass, right? Okay, which means that I could switch all of this off now. None of this would run, and then this code down below would all run. So that's a nice way of controlling the flow of code. And in fact, I'm going to utilize that, because now if name equals main, it just kind of like passes, so none of that stuff gets run, because basically the main module never gets executed, and the main module is a thing that calls Flask. So the class is constructed. These two things exist in memory space, but they never run, basically because we just literally commented it out. So when we run this now, we can, so here I can put like def test code, right, colon tab. I no longer have to worry about commenting things out, but basically our test code is going to, in fact, I can do this, I should do this really, X over here, so like put it right down here, right, if name equals main, because now I can just do test code instead. So there were different ways of manufacturing the same thing. So I don't have to have this even as a separate snippet of code now. This can all run. And we can see what's going to happen now. So here we're just going to do test code. There we go. And that's going to set the proof of work to 1. Then it's going to do proof of work on whatever the proof of work is. It's going to spit that back out into the result. And so whatever the return value of this is going to be assigned into this result. And then we're going to print result. Now we've got like a testing function inside of our code. And if I do F5 to run this, it is now going to run inside. And here it goes. I wonder why that's going slow. Is it doing work? Okay, it spat back out this, right? Which I presume, well, that is the result of the proof of work. So when I hovered over it, did it say proof of, yeah, okay. So somewhere in there I could have, I guess what went in there, previous proof. It was irrelevant what previous proof was. So previous proof was the only thing that we cared about. Now, this result, we're going to do this, which is for I in range, say 5, the results, the previous proof is the previous proof. So we're going to like feed it back on itself. And we're going to print out each of our previous proofs, I guess. So our previous proof is going to start as 1. It's going to go as 1 in the function. It's going to return something back, which was this 632238. Then it's going to take that previous proof, and it's going to that's going to go be fed back into the function to minus this squared. And the new proof here, this is always 1. This is the bit that's odd, because this new proof bit is always 1 squared, which is just 1. So I don't quite get that. 1 squared minus previous proof. I don't get the purpose of new proof being, well, okay, like why not just put 1? Well, I guess I suppose it's a variable, so we could have put in 10 or something else. But then new proof here, it makes more sense for new proof. So like new underscore proof equals 1 to be like a keyword argument, basically. So if you don't specify anything, that new proof is always 1. That's kind of that would sort of like make more sense. And I don't know if new proof needed to be an integer or not as well, because it looks like whatever is coming back from this SHA here, it says returns back underscore hash on this SHA 256. I'll go and have a little look at that. Okay. So I'm just going to try and run this again now. So F5 to run it again. But we're going to do this, I guess it's going to go through this loop 5 times, which should do. So we've got the first value, which was the same. Then we got another value. You can see it's doing work. It's slow in the meantime. We get 5 values there, and then it finishes. So that's actually what's happening. That's what this proof of work function actually does. And I guess one thing I could have done was creating actually a class just outside of that to investigate. So I didn't need to do this proof of work thing like that with this test code. Make this kind of like, this isn't like required in the code, but basically here we go. So like, you know, these are things that we like don't touch or whatever. They're private methods. Right, just like to avoid any confusion. But anyway, there's no confusion because the other proof of work method is wrapped inside of a class. So, but this is generally, I guess, you know, I don't even need to double underscore it in a way. I'll keep it double underscore, but this is a proof of work, basically. And I guess you're going to have to keep on mining, and I presume it's good. Well, I'm presuming that it's going to get slower and slower as the numbers, these 000 things, get exhausted. Like finding something that begins with 5 zeros in the beginning, it's just going to become increasingly harder. And that's basically part of the whole proof of work ethos if that the calculations become incrementally harder. So the mining operation becomes more difficult, and you're required to put energy into the system that way. So yeah, that's all good. Let's go back to this blockchain function then. So we now know what this, where is it here? We have an idea of this proof of work, which runs this while loop and demands us to perform a calculation to find the next proof, given that we've got like the previous one that was calculated. And by the way, if we stuck in an extra 0 here, I'm not going to do it, but it'll get really slow and it might even grind to a halt, because this laptop probably isn't, I don't know if it's faster. If you've put in too many zeros, you're really increasing the complexity. I remember doing it years ago, and I did it with 4 zeros, so 5 zeros seems to be used now. But yeah, that's that. Now let's just see this hash thing here, def hash self block. Okay, what's actually happening here? Again, self is not used anywhere in this particular function, so it's a, whatever we called it before. What did I refer to it as? A static method, basically. So it's another static method. But here, hash, the encoded block, JSON.dumps. So that's just going to serialize object to a JSON formatted string. So whatever it gets there, it's going to be printed as a string. This block, let's have a look. Where's block created? We don't know. Sort keys equals true.encode. Okay. And then, okay, it's just encoding it and then returning the hash of that. Okay, so that's basically all it's really doing. It's returning this. We see this hash here. It's the same hash function used down below. So we're hashing things, basically, is what we're doing in different ways. So here we're hashing our encoded block, and we're calling that the hash itself. And what else is there? Chain valid. So again, a doc string is required, really, because I don't know what chain valid is without reading it. I wonder if it was in the original docs somewhere, but I copied it all out. At root. Yeah, chain valid came with no description of what it is. So, is it easily describable? Let's have a look. It takes in chain. I don't know what chain is. Why do I not know what chain is? Because it's not documented anywhere. So chain could be anything. Chain is any. Right, great, fantastic. Previous block. Is chain just our list? Yeah, chain is our list. Self.chain is over here. So, but is that chain the same as our self.chain? I wonder. No, it wouldn't be. It's going to be something else. Previous block equals chain 0. I guess it's checking if a chain is valid. So chain must be of type list. Right. I'm thinking that chain should be this. Right. Which is just a bit more helpful, that's all. I wonder where else chain comes up. Chain. Right. Because over here, I guess, well, it still says any, funnily enough. Here it's any. Where else does chain come up? Len of chain. Chain is any. I'm sure it should be a list, right? I've had to backward infer that. I guess maybe someone might say it's obvious because chain 0 here, like what you're expecting. It's just when you create functions, it's kind of like, you know, I guess it's good practice to sort of like tell the user what's in the function, and in other languages you're forced to, and in Python you're not. So you can get this really nice short, concise code that's supposedly easily readable, but the question is it actually easily readable at all? Because is it easily readable? Because I don't know, like, you don't know what all of these variables are per se. Now, if the function's short, I guess you can kind of like figure it out. But it would just help, like a one-liner would help in the docstring, and you know, the type hinting here would help. So we'll go with that, and then just like check if the chain is valid. You could say that's not really very helpful because this thing here is chain valid, but maybe it means validate the chain. I've got no idea. But it takes in one argument, which is the chain that we want to test, I presume. So chain is a list. So here we say something like, you know, chain or args chain, which is a list. You know, the chain that we want to, or not we, the chain to be validated, right? So something like this, and also it's returning back returns and something like, I guess, true or false. True if something, or false. And I don't know what the conditions are. If I presume true if valid. Or false otherwise. So something like this sort of like tells you, or tells the user what's actually happening. But anyway, let's just go in and see if that is the case, and if this docstring is correct, and if this chain is actually a list, and so forth. But we take our previous block, and we take the first index of the previous block. Yeah, the first item in the previous block. And block index, we just say block index equals 1, okay, and then while block index, and block index, remember, is 1 here, is less than len of chain, okay, which is less than the length of our chain, okay. Block equals chain of block index, so let's have a look at that one. Block equals chain 1, because block index is 1, basically. Block index was set to 1, so while block index is less than that, if block, is chain actually a list, or is it something else? Because what is block here? Block is of type any as well. Fantastic. Block is of type, okay, so chain of block index, so chain of 1 in our case, is going to be the block, and if block previous hash is not equal to self.hash previous block, So our previous block is chain 0, return false. So previous proof equals previous proof of the block. Okay. I don't know if chain is here, if chain is a list or a dictionary. If it was a dictionary, well, chain 0 would still be that. So I don't know what this is. So I'm just taking this out for now, just to be, because I don't want to assert that it's something that is not like what we're expecting in here. But I'm going to try to run through this, right? Def chain, okay. Block index here is 1, so we start off with a value of 1. So while block index, while 1 is less than len of chain, we don't know what. I'm presuming this. Okay. Right. If this one return false. I'm wondering what block previous hash actually is. Because this is like a dictionary item here. I'd expect it to be like self.block.previous hash. So I'm actually wondering how it even works. I'm just wondering where block previous hash comes in, because here block is, this must be the whole blockchain that gets fed in, and I think that this chain then is somewhere is this block here, which is this previous hash here. That's what it actually must be. That's logically what it is. So it's checking the previous block each time, and if it finds that it's not valid, then it will return false, and that's why that check is done first as well. I guess to because then you can break out of the loop quickly. If you, the minute that you find a previous block, there's no point doing any more calculations. You might as well just break out of the loop. So it's traversing down this list, this linked list, I guess, in a way. Previous proof equals previous block proof. Okay. Proof equals block proof, and so forth. Right. It'd be nice if this was commented. Again, I can sort of like break this out. This def chain valid bit. I can break this out here into its own isolated piece of code. Sorry, didn't mean to do all of that. Basically, this little chunky of code over here, I could break it out into its own little section to check, given a chain, which is like this list. I guess it's possibly like a list of dictionaries even, where there's our blockchain that are linking each item to the next. If that is valid, then we're going to be returning a true, and otherwise we're going to return a false, basically, and that's pretty much it. So that's one check that gets done here if the previous hash is not equal to the hash that we calculated, self.hash. Then that's one check that we have to do. But the other check that gets done is if the hash operation, the first 5 digits of it, doesn't have this nonce of 5 zeros, that's also going to return a false. And we set the previous block equal to block, and then go back and restart the while loop, and we say block index plus equals 1 as well. So our block index starts at 1 and then keeps on getting incremented, so while block. So that's what actually happens here. So we can check every item in the chain. That's actually what's happening. So we start at index 1 and we go until we're like less than the length of the chain. And each time we're stepping through, so we check block 1, then check block 2, then check block 3, then check block 4, and so forth. So the only thing is previous block equals block. Okay, fine. And I presume there's always a previous block. That's basically it. Okay, so that's pretty much it, really. That's everything. Funnily enough, that's everything that's required to create a blockchain. So a blockchain is actually a very simple process in a way. Like once you get your head around it, it required this hashing library. I should really put more comments on this, but basically it required this hashing library over here, and we had a bit of date time and so forth. But outside of that, that's really it. Now everything else is just wrapping this into the Flask application, which is, so I can close up this blockchain one. We don't need this proof of work or this thing here either. But we'll go back to the main piece of code, and we don't need our test anymore. Remove the pass, we can hit save. But basically everything else is in the Flask app, which is we create our Flask application, and then we, somewhere down below, wherever it is before the end of the thing, we run our Flask application, and that's basically the end of everything. There we go, return. There's nothing else to do, and everything inside of it is the different web pages or things that we can do. So we can show our full blockchain over here with the display chain. We can validate it, and we can mine. We can mine a block, so we can just keep on mining blocks. The blocks get added into the chain. We can then do get chain, so we can view our chain on in the browser. It's not like particularly pretty how it's done, but we can view the chain in the browser. We can see this JSON string of this chain getting bigger and bigger in the browser every time we run this page. We mine one block. So every time we do the mine block, we run one block. We create one block basically, and we can see our chain, and then we can validate our chain, and that's basically it. That's it's as simple as that, really. So you've got a complete blockchain. Not complete blockchain. You've got like this fundamental building blocks for the blockchain in Python, using a Flask application, and which means that you can see the results in the browser. Now, we don't have to see the results in the browser if we don't want to. We can sort of like print our stuff to the log to the console or somewhere else. But yeah, this particular one was given in the browser, so that's kind of like what all of this stuff over here, which is just all of this run Flask stuff, was just getting our blockchain class methods effectively running. So, and in here, all we had to do was one thing, which was create an instance of the blockchain inside of our Flask app, and that was everything. We could then start calling our methods inside of there. So, blockchain dot whatever it was, and expose our methods. So, and it's as simple as that, i.e. literally blockchain dot, and these are the things that we created. So chain valid, create block, and this is where the doc strings sort of like come in useful, which is here. Sort of like it tells you check if the chain is valid, the chain to be valid, and so forth. And if you haven't labeled it, then the user has to start guessing as to what they are. Even if you just put some simple stuff down, like I'm a big fan of it, because when I come back to my own code, let alone someone else's code, I can't even remember what I've done like 3 weeks later. So without the type hints and so forth, and type hints are optional in Python. In other languages they're forced, but the reality is when you're reading it, I don't know if it's more. I actually find it more readable with the type hints actually being there and with them not being there. So a lot of these structured languages are, because you're told what they are. It's an integer. It's this or that. It has to be of each variable always has to be of a certain type. So it's kind of like nearly. I'm going to say like it should be nearly mandatory to force it. Like in a way, you could consider it bad practice to not be a type. I know that you could say, well, maybe the type is obvious. So it's kind of like swings and roundabouts for that. But yeah, if you are gonna make functions or whatever, then it's probably worth labeling them in some way. So that's pretty much it. I might end the tutorial here. If anyone's got anything to add, that would be interesting to see. I'll just see if there's been any comments in the meantime on the live server. No, there's been no comments. So yeah, that's basically it. So I'm going to stop this tutorial, not even a tutorial, like a little video of me going through a blockchain that in Python that was created, that I've pulled off of the web. There's like loads of different versions of it. If you found this useful, hit the like button, hit the follow button. If you didn't find it useful, still hit the like button, still hit the follow button, hit the subscribe and all the rest of it. And also comments, put your comments in the section down below too, where you think that you can add value. If you've got a better version of it, put a link in there to the better version. And that's it. So that's the blockchain in Python.